So we're going to go ahead and take a look at our third method in solving these systems of equations. Probably one of my favorite methods. Our first method was graphing, where we graphed and we identified what the solution was. Then we used substitution. This one we're going to use what's called elimination. So can I solve systems of equations by using elimination? We still have two equations. And so we are literally going to eliminate one of the letters. And so you want to look for, in each equation, if there's a coefficient that's the same. And first of all, let's also change this, subtract 5y to add the opposite. So it's a negative. And so I'm going to go ahead and I notice that my y's are the same. They have the same coefficient. One's a positive 5 and one's a negative 5. What can you do with a positive 5 and a negative 5 to get 0? You add them. If we take 5 plus negative 5, we get 0, and that's our goal. So we're going to add these two equations together. And this is how it works. 2 plus 6 is 8x. 5 plus negative 5 is 0. We eliminated it. It's gone. And 17 plus a negative 9 is a positive 8. And so now we just solve for x. And 8 times x, the opposite would be divide. Whatever we do to one side, we do to the other. And x equals 1. So remember, we are looking for an x value and an y value. We're looking for an ordered pair. Now that we have our x value, we're going to pick one of those equations. I'm just going to go ahead and pick the 2x plus 5y equals 17. I'm going to go ahead and I'm going to plug in the number 1 for the x. We are going to substitute. So now all we have to find is what our y value is. So we have 2 plus 5y equals 17. We're just going to solve for y and get it by itself. How are we going to do that? We're going to subtract 2 from both sides. We have 5y on the left. 17 minus 2 is 15 on the right. 5 times y, the inverse is divide, and your y value is 3. So this is a 1 solution. The ordered pair is 1, 3. That's where these two lines, if you were to graph them, that's the ordered pair they would be going through. So this is our elimination method where we are either adding, and I'll show you an example where we're going to subtract, but we're either going to add or subtract and combine our equations. Was by literally eliminating one of the letters by either taking your two equations and adding them together or taking your two equations and subtracting them. That's it. Example 2. I want you to notice, let's go ahead and I'm going to plug in what number is going to go in front of the b if nothing's written. Well, it's the number 1. So these coefficients are the same. My b's have the same coefficient. They both have a number 1. Now I want you to think about it. If I have 1b and 1b, how am I going to get 0 and eliminate them? Are you going to add those to get 0? No, we're going to subtract. So we're going to take 1, take away 1. So we're going to subtract these. So I'm going to subtract my equations. So we're going to have 1 take away the 2.5a. And we get a negative 1.5a is equal to, we know 1 minus 1 is nothing, so that cancels out. And 101 minus 164 is a negative 63. And I highly suggest that you use a calculator with the subtracting. Remember, the top number, subtract the bottom. And so now, to get a by itself, we're going to divide by that negative 1.5, and a equals 42. Okay, because these letters are A and B, we'll just go ahead and put A for the X and B for the Y. It's usually alphabetical. So my A is 42. So now let's figure out, what is my B value going to be? Well, I'm going to use that top equation that says A plus B equals 101. We know A is 42, so I'm going to put a 42 in for the A. And in order to get the B all by itself, we're going to subtract 42 from both sides. So this is 0. And I have B equals 101 minus 42 is a 59. So this is also an example of a one solution. Your one solution, this wouldn't be fun to graph. When you've got decimals in your equation and your answers are very large, so this would not be a fun one to graph. That's why we have other methods to solve besides graphing. Let's go ahead and look at our last example. Today, what we looked at, what I think you're going to notice in our last example is that I don't have a coefficient that is the same. I have my x's that have a -2 and a 7. Those aren't the same. And I have my y's that are 15 and I'm going to change this to a -5. And so we're going to have to actually make them the same. So how do I do that? Well, I know that a -5, if I times that by 3, I'll get 15. So I'm making it the same. So first of all, I want to say I'm doing nothing to this top equation. It's going to stay -2x plus 15y equals -32. I didn't do anything to it. This bottom equation, we are multiplying everything, even the answer, by 3. So we're going to end up with a 21x plus a -15y equals, and 3 times 17 is 51. So now that we have our y's, where they are the same coefficient, 15, one's a positive 15, and one is a -15. So if I have a positive 15 and a -15, are you going to subtract those or add those to get 0? We're going to add them. So we want to add these two equations together. So -2 plus 21 is 19x. Positive 15 and -15 is 0, a big 0. That's why I circled it as 0. And a -32 plus 51 is 19. So now we just need to go through the solving process to get x by itself. Divide both sides by 19, and x equals 1. So we had an additional step with this problem where we needed to make one of the equations have the same coefficient. Remember, we need an ordered pair in the form of x comma y. We know our x value is 1. Let's pick one of those original equations. I'm just going to go ahead and take the -2x plus 15y equals -32. I'm going to go ahead and put the number 1 in for x because that's what we just found. -2 times 1 is a -2. We want to get the y by itself. The opposite of a the opposite of a -2 would be add 2. Whatever we do to one side, we do to the other. So I have 15y is equal to a -30. I'm kind of running out of room. I'm going to write over here to the side. So if I have 15y equals 30, I'm sorry, negative 30. Don't lose that negative sign. To get rid of that 15 times y, the inverse of multiplication is to divide. We're going to divide both sides by 15, and y is a negative 2. So this is a one solution because there is one ordered pair that will make both of these equations true, and there is one ordered pair that they both cross at. So these two equations are going to cross at the point 1, negative 2. So we have many different ways to solve systems.